Hello everyone, my name is Sarveshwara Kosuri. Today I am presenting my project on character level text generation models using PyTorch. The objective of this project was to build, train and compare two fundamental neural network models architectures, an LSTM and a mini transformer, entirely from scratch. The goal is to see how well they can learn to generate Shakespeare's text character by character. Now opening the model lstm.py. Let's take the quick look at the architecture for the recurrent model. I used PyTorch native NN.LSTM module mapping the hidden states back to our character vocabulary using a fully connected layer. However, the transformer model was built. Transformer model was built entirely from scratch. However, the transform model is done without using PyTorch high-level transformer primitives. As you can see, I implemented the positional encoding to give the model a sense sequence order and the multi-head self-attention mechanism complete with the casual masking so the model cannot look ahead at the future characters. Positional encoding. Making so model can look at the future character during training. To ensure this project is 100% reproducible, the entire environment is containerized in the Docker, explicitly pulling CPU version of PyTorch CPU, and image lightweight. Now I'm switching to the text editor. Docker comp. I'm running because trying these models from the scratch takes over on a CPU. I already pre-trained the both models and saved their weights in the models directory. Right now, you will use the Docker Compose to run the evaluation and generation script live. The command spin up the container. Sorry, the Docker is running. Sorry with the problem. It's I'm using the backslash for the path. That's why it's not given throw an error. Now it will be fine, working fine. It's computing the LSTM perplexity, computing transformer perplexity, generating samples. Right now, I will use Docker Compose to run the evaluation and the generation script live. Three different temperature settings. Now I'm opening the results folder. I'm showing the losscards.png. No, first of all, the loss is started for the transform model. It is 2.5, nearly 2.5, and it is reduced to 1.9 or 1.8 nearly. And for LSTM model, it it is 2.05 like that 01, and it is reduced way to 1.2, which is very great result. We can see both models successfully converged without exploding gradients. Thanks to gradient clipping, the LSTM achieved a validation perplexity of 4.56, outperforming the minimum mini transform which scored 7.97. 4.56, which outperforms the mini transformer with 7.97. This makes sense for a small character level dataset, as transformers typically require massive amount of data to overcome their lack of built-in sequential bias. Look at the generated samples. Look at the generated samples here at a temperature of 1.0. The models produce a fascinating imitation of Shakespeare that LSTM does a fantastic job with local phonetic structure, closing codes, and spelling words accurately, I think. The transformer, despite a higher perplexity, shows an impressive ability to capture the high-level structural format of script, specifically learning to output character names in all caps followed by a colon. Now, this is the result space. LSTM loss.json from 2.01 to 1.48, and finally it comes to 1.205, like that. For transformer 2.48, it started from 2.48 and it became 1.940, which is very impressive. And finally we conclude the project. uh, I'll show you the preview of and preview our project. Building the multi-head detention blocks and managing tensor shapes from scratch was challenging, but it provided deep under the hood understanding of how modern large language models LLMs operate at their core. Thank you for the taking time to review my project and video demonstration. Thank you.